First thing we're going to do on page 431 is we're going to highlight a new formula. So again, for all of our word problems, what we're just trying to do is we're just trying to get used to working with different formulas. And on the exam or on quizzes and tests, you will always be given a formula and everything will be described what it means. Okay, so this is looking at a series of equal investments is made at equal time intervals. Maybe you want to save up money and you want to put $100 away every month. How much are you going to have if you get 5% interest compounded monthly? How much are you going to have after 5 years? How much are you going to have after 10 years? How long would you have to wait before you got $20,000 and could buy the vehicle that you want to buy? So this is a formula that figures out those kind of things. It figures out the future value when you make a regular investment. Here it says I is the interest rate per compounding period. So if you did it monthly and your interest rate was 7%, you would put 0.07 divided by 12. And we'll do that when we get to our first question here. So you're working and you want to save some money. So you decide to put $200 a month away into an account, and this account pays 6% annual interest, compounded monthly. How long do you have to wait before you have $100,000? That's a lot of money, $100,000, just putting $200 a month away. So we take out our formula, and again, it would be written like this and everything would be explained in the question. So you've got R, 1 plus I to the n, minus 1, all over I. So we want a future value of $100,000. We're putting in $200 per month. The interest rate is 6% compounded monthly. So the I part in this formula, you write the percentage as a decimal, and since it's compounded monthly, it's 12. Minus 1, all divided by, again, the I, so that's 0.6 over 12. Again. Now this formula is busier than the formulas we were doing on the sheet the other day. That's why we did those ones first. They were more simplistic. This isn't necessarily that much harder, but there's a little bit more preliminary work that you need to do. So what I'm going to do is I'm going to put a box around the power. The preliminary work is that you have to get that power first by itself. We want to solve for n. N is in the exponent. We're going to need to use our logs and our log laws. But things are going to be easier for us if we first get that power by itself. So I just sort of have to undo order of operations. What would I do first? I want to get rid of this 0.06 divided by 12. How would I do that? I would multiply both sides by 0.06 over 12. And if I do that, I get 500. Kind of annoying. Rewrite everything again. There's my power. So what would I do next? Order of operations, I divide both sides by 200. Dividing both sides by 200, I'll get 2.5 here. And now can you see when you divide by 200, those big square brackets aren't doing anything anymore? I mean, you could still write them here, but technically you don't need them anymore. What do I want to do? I want to get my power by itself. And you see that there's only one thing left to do. You have to add 1 to both sides. And then we can use our log laws. Which allows us to bring that n out in front. Now if you divide both sides by log of 1 plus 0.06 divided by 12, take out my calculator here. Log of 3.5 divided by log of 1 plus 0.06 divided by 12. 251.178. Does it ask us to round to anything? Or it's 3 decimals? Determine how many. Well, you can't make a partial payment. Now this is an interesting rounding thing. It rounds to 251, but would you get to 100,000 with 251? No, you'd be just short. Sometimes when we round things, we have to round up even if it's not the closest number. For example, painting. If you need 1.1 cans of paint to paint a room in your house, will you buy 1 can because it rounds down to 1, or will you buy 2 so you have enough paint? You have to buy 2. So sometimes we need to round up. Sometimes the exam is really good about it, like here I did my 3 decimal places, and then if I make a statement saying I have to round up or round down, they're probably going to accept both of them. If I just wrote 252, they might take that off. But if I show my work that I got 3 decimal places ahead of time, the worst that could happen is I could lose a half a mark in my rounding. Interesting in this question. If we just scroll up here, okay? All of this work that you can see right now, if this was a provincial exam question, they would give you a half a mark for doing all of this work. Because this is considered pre-grade 12. Plugging things into formula and rearranging an equation, that's grade 9, 10, and 11 work. Then on the exam, taking the log of both sides, this step is worth 1 full mark. Because this is new for grade 12. And then using your exponent law and bringing it in front is another full mark. Those 2 lines, which are really easy, all that previous stuff was a half mark. This would be another 2 marks. And then getting n by itself and getting your answer is your last half mark. So this would be a 3-mark question. But the majority of the marks are where you're doing something new from grade 12, which is using logarithms and using your log laws. So that's why Sometimes I'm like, be careful, take your time at that, because this is worth 1 mark, this is worth 1 mark. If you did this in one step, they would give you 2 marks for that. But if you make a mistake in that step, you have a possibility of losing both of those marks at once. I'm going to show you something pretty cool on your calculator. For those of you that have a graphing calculator, this is the number one thing that I've used outside of school for figuring things out. It's under apps, it's under finance, and you can find, it's called TVM Solver, T for time, V for value, M for money, and you can find apps online that will do something similar. But what this program is set up to do is to figure out exactly what we just did. It has a bunch of things to plug in. N is the number of payments. In our question, we didn't know the answer to that. I is the interest rate. So in our question, the interest rate was 6%. At present, you start off with $0 in your account. And then you're going to be putting money into the account. Now, for the graphing calculator program, it has, you have to know how negatives and positives work. And for this program, it says anytime you would take money out of your pocket and either pay someone or put it away in the bank, you put that value in as negative. So since we're taking money that we got from our wallet and putting it into the bank account, we're going to put this in as minus 200. The future value we want to equal $100,000. We are making monthly payments, and where it is compounded 12 times a year. And then you go to the one you don't know, which is N, and hit the alpha button, because above the enter button is solve, and you can solve it and you get the exact same answer, 251.178, which if you divide that by 12 is about 20 years. Okay? So just think, if someone had decided to do this for you, right? If you had a very nice grandparent who said, when you were born, I'm going to put $200 away for you every month, and then I'm going to give you a present when you turn 20, that would be a pretty nice present. $100,000. How much did it cost your parents or your grandparents? Well, if I take this 251 and I can actually do math in here and say times by $200, this is how interest works. This is pretty cool. It only cost them $50,000 to give you a $100,000 present. Because you were making money on your interest. So if you can start thinking about how you would like to invest, right? Everybody likes it when they can take something and get more for it. So if you can save money, invest money, this is what could happen. Okay? But it all depends on the interest rates. If we only got 2% interest, and instead we want to see how much you would get in 20 years, 20 times 12 would be 240 payments. Now 2% interest in 20 years, I can go alpha solve here. Oh, much better to get that 6% interest, right? Because now 2% only gives you $58,000. If you got 9%, are you ready for this? So one set of grandparents got 6%. That kid got 100 grand at their 20th birthday. Another one only got 58 grand. And then a 9% person gets, alpha solve, $133,000. Now, these questions are nice to imagine and think how nice it would be to get that amount of money. But unfortunately, for most of us in real life, we don't save money. And we don't invest it this way because we spend money. In fact, for most of your life, you will spend more money than you have and owe a bank or somebody money because you're going to either buy a car or buy a house. And like your parents probably have been in debt for most of their life because you're paying someone. So this, although this is nice to think about, usually you have debts to pay, so you don't have money to put away, even though it'd sure be nice to get an extra $50,000 for free. Unfortunately, you're paying money. So that takes us to our second formula. And questions for practice on this first question are 3, circle 3 and 6.